Hi guys, my name is Chris, and I'll be telling you about my project 1 and the three tasks I'll be covering. I'm focusing on the grade level 7th grade. The cluster is draw and form a comparative inferences about two populations. Math content, there are two of them. Informally assess the degree of visual overlap of two numerical data distributions with similar variabilities. Measure the difference between the centers by expressing it as multiple measure of variability. And then the second one, use measures of center and measures of variability for numerical data for random samples to draw informal comparative inferences about two populations. My two sources are making sense of data, context matters, and the second one being intervention, activity support, statistical reasoning. Here's the first one, statistical reasoning, as it gives more insight on students analyzing data based on collecting their dot plots and bar graphs here. This one being similar as well, but with different ideas and conception, different idea of how students should be analyzing data as well, but very similar. So moving on to the task. Task 1 is about the offensive linemen. College football are grouped with similar teams with different divisions. Based on many factors in attendance, level of competition is separated in Division 1A, are typically from much larger schools, and of any other division. Division 3 representing the smaller school. So from the 2012 season, they collected this data, showing, I believe, the weights. Yes, the weights of the different linemen in pounds. And of course, there's a significant difference of the amount of linemen from Alabama to Mount Union. And the questions will ask, based on the visual inspection of dot plots, which group appears to have the larger average weight? Does one group seem to have a greater variability in other weights than other? Do the two groups look similar in regard? Compute the mean and mean absolute deviation for each group. Do your measures support your answers in part A? Choose the following in blank. The average Alabama offensive lineman's weight is about the average of lineman's weight. And then there's like a multiple choice here for these two ones. The difference weight is approximately about half the MAD, slightly MAD, twice the MAD. MAD showing about the variability of the data based off the mean. This last question was pretty interesting because this is where it makes students think a little bit more beyond the data, where it says, if these were random samples, would you think that the offensive linemen for FBS schools are typically heavier than the offensive linemen from Division 3 schools? Explain your decision using answers to your previous questions and additional analysis. Now, to analyze this task, I decided just to pull up this chart that we used from our reading from the I believe it was the Geis reading. Yeah, hopefully I didn't say that right. So formulating questions is typically a level A, as the teacher posed the question for interest. So this is something that was directed to the students as they follow it. Collecting data as well, the data was given, so it was just pretty much a simple experiment. However, analyzing data was around a level B, as they were able to compare group to group in displays, and also learn to quantify variability within a group. So it's about a level B. When it came to interpreting results, I wanted to say it was around like more towards the level B as well, especially with that last question that was shown. This last question, part D, will fall under around level A, I think level B, because they are asked to acknowledge that look beyond the data that is feasible, and to note the difference between groups with different conditions. For the second task, this was one on the on the illustrative mathematics, and it just happened to be the example as well as the professor gave us, so I decided to keep it and we just analyze it well. Plus, this ended up being kind of the foundation of how I made my task 3. So with this one, this took two different types of athletes. One was field hockey player heights and basketball player heights in inches. And the data was spread out in dot plot as well. Based on visual inspection of the dot plots, which group appears to have the larger average height, which group appears to have the great variability in heights. compute the mean and mean absolute value, MAD, how many of the 12 basketball players are shorter and tallest field hockey player. Imagine the athlete from one of the two groups needs to go to practice. You estimate 65 inches, and if you did, are they considered a field hockey player or a basketball player? Explain your reasoning. The women on the Maryland field. So this, and then with this one as well, kind of reminded me of the last task, having the students think a little bit more critically. Where if these random samples, would you think that the female college basketball players are typically taller than female hockey players? And explain your decision using the answers to previous questions and additional analysis. So again, I want to say that the level of questioning again is level A, and analyzing the data is, and collecting data is around level A as well, because the data is given again. And then so collecting data was level A, formulating questions was level A, and also analyzing data. Analyzing data was around like a level B as well. As again, students are asked to look beyond the data that's feasible, and again, note the difference between the two conditions. Note the difference between the two groups with different conditions. And for interpreting results, again, very similar to the last task, students acknowledge look beyond the data that's feasible, and difference between two groups with different conditions as well, just based on that part E. Now for the task that I chose, I decided to use my old school UCR's athletes, and I made a spreadsheet of data as well for the students as well, to note that there's a big difference between the amount of athletes in the different sports. So we have men's soccer heights and men's tennis heights. Students would think that there will be a big difference in means between the two groups just based upon the data, based upon the dot plot. However, in this question, when they start making the box plot, they start to see the means and the medians of actually being very close and very similar to each other. So when it comes to these types of questions, find the mean and the MAD. How does it compare to your responses? Now calculate the median of the two groups. They're going to see that these values are very close to each other, despite the fact that their quantities are so different. As you can see, the quantities are significantly different in the 2016 roster sheet for UCR. So first, they're going to be analyzing the data in terms of the dot plot with their first conjecture, and then they analyze the data with the box plot and notice that there's something notice that the results are actually pretty different. Kind of took the idea from text 2. If they had these different heights of athletes, where would they participate in? And then finally, I will want them to expand their reasoning on what would change the mean and medians of the tennis players if we were to add more variability and more outliers, and just they play around with the data and see how that changes and how this relates to the soccer team as well. And that is it for my tasks. Let me know if you have any questions about anything I talked about. Thank you.